Hi there, welcome to my first podcast from option A, which considers the eye and wave phenomena. The first segment I'm going to be looking at is the eye. So during this session I hope to identify the different parts of the eye and their roles and explain how the eye works as a whole. Okay. So let's start off with considering the eye and the different parts. So I've got a cut through of the eye. I'm going to introduce some different parts. We're going to kind of rotate around. So to start off, we have the iris. Now the iris is the muscle that opens and closes the pupil. So that's the thing which allows your eye to get larger and smaller depending on how much light is required in the eye. Then we have the lens. The lens is what focuses the image onto the retina. The retina is going to be at the back of the eye, and we're going to come to that in a moment. The pupil is the gap in the middle of the iris. Okay, so this is the where light comes through. In front we have the cornea. This is the part of the something larger which is called the sclera, and it lets light through. So it's the I guess the clear part of one of the outer bodies of the eye. We have the ciliary muscle. And this is attached to the suspensory ligaments and it supports the lens, so it keeps it in place. The sclera, and the sclera is a kind of an outside surface which protects the whole eye. The retina. Now the retina is at the back of the eye and it's what light is projected into, and it contains the light receptors, which we're going to talk about in more detail later on. We have the optical nerve, and this takes information from the receptors back to the brain, so that's where information is processed. And we have the suspensory ligaments, and these are attached to or support the lens. Okay, so there's another feature of supporting the lens. So there's key features. If you haven't had a chance to jot those down, I've just put this into a table. So I'll repeat again. Contains light receptors, that's the retina. Focuses the image on the retina, that's the lens. The gap in the middle of the iris, that's the pupil. Is attached to the suspensory ligaments and supports the lens, that's the ciliary muscle. The muscle that opens and closes the pupil, that's the iris. The part of the outside surface that lets the light through, that's the cornea. Protects the whole eye, the sclera. Attached to and supports the lens, the suspensory ligaments. Takes information from the receptors back to the brain, that's the optical nerve. And protects the eyes from dust, those are your eyelashes. Okay, so that's the structure, the parts of the eye. Now, how does the eye work? The eye obviously sees things at different distances, so it has to accommodate for that. For objects which are a long way away, light comes into the eye relatively parallel. And what happens is, once the light reaches the lens is adjusted so it bends the light, so it projects the image directly onto the retina. How this works is, the ciliary muscle relaxes and the suspensory ligaments pull tight, making the lens thin, and therefore light doesn't bend very much in relative terms. For closer objects, what we see is the light is coming from a closer point, so therefore it's spreading out more. So that means that the lens needs to put more work in bending the light. So the ciliary muscles contract, allowing the lens to go fat, and as it's fat it causes more refraction and bends the light more effectively. Okay, so I'm just going to repeat this in a different context, and you can think about what we need to do to make adjustments to improve our sight sometimes. So thinking about this, if we have a magnifying glass, and a magnifying glass using the sunlight would be able to focus the light onto a piece of paper. Now if I change the magnifying glass and use a candle, what would happen is that the image which the original glass, or the point where the image was originally would now be blurry, and I'd have to move the paper back to get a clear image. Now, obviously, I can't just elongate my eye when I see things closer, so that's not a suitable method. What I have to do is increase the lens power. So if I want to focus something which is close to eye, I can increase the lens power, or I could add a second lens, for instance reading glasses, which would bring the image to focus at the point which I want it to. Now, the retina, which is at the back of the eye, is where we find the two types of photoreceptors. These are rods and cones. Now, the rods are more numerous. There's about 120 million of these, and they're actually much more sensitive than cones. The 6 to 7 million cones provide the eye's colour sensitivity, and they are much more concentrated in the central yellow spot known as the macula. And in the centre of that region is the fovea centralis, which is about a 0.3 millimeter diameter rod-free area with very thin, densely packed cones. So the cones give us colour, but the rods give us a distinction between light and dark. So as we can see here, if we look at the different types of sensitivity, rods are designed for low light conditions, where distinguishing colour is not important, but the difference between light and dark, and they are much, much more sensitive. Cones, on the other hand, are designed for well lit conditions, and they cover a breadth of wavelengths, so they can distinguish colour more effectively, and they're more effective in well lit conditions. Now, also notice that the rods are crucially found towards the the edges of our sight. So this is very, very useful, because what it means is, and what you might find is that you sometimes react very quickly to things coming to the edge of your vision, even though you haven't seen them properly. Now, this is because the rods are very sensitive and they're aware of things in our peripheral vision. Thinking about cones specifically, there are actually three types of cones. We've got red cones, which make about 64%, green cones, which is 32%, and blue cones, which are 2%. Now, these three cones work together to be able to distinguish between the different colours. And as you can see, because there's an overlap, it allows us to work out exactly what wavelength light is coming in, to be able to distinguish exactly what colour there is. Now, colour blindness occurs most often actually due to the inability to distinguish between the red and the green cones. So often people who are colourblind just struggle to distinguish between those two colours and to work out subtleties in shading in that area. My final thing to talk about is colour mixing. Okay. Colour mixing is just the idea how colours, when the light combines, we see different lights forming. So for instance, we have three primary colours, which are red, blue and green. Now, if red and green light combines, we see yellow light. If red and blue light combines, we see magenta. Blue and green gives us cyan, and a combination of blue, green and red produces white light. So that's about our perception of how colours mix. This can also be considered when we think about filtering. If we have a blue filter, it would block off the green and red primary colours, but only allow the blue colours to come through, as with the green filter or a red filter. Now, if we think of a filter which is a secondary colour, if we had white light coming in, what happens with a magenta filter is it would allow red and blue light to proceed through. White light would block the blue light. A yellow filter would block the blue light but allow red and green to come through, and a cyan filter would block the red light but allow the green and blue filter to come through. I hope that gives you a full overview of how the eye works and the features which are important.